Hey guys, today we are talking about exponential growth and decay functions. And it's exponential because as our time increases, it increases our exponent, an exponential factor of our function. And so exponential functions can be used to represent anything from that changes at a based off of a percentage year by year. Okay, so you can think about even like the pandemic, right? It changes over time. Month by month it can increase, or week by week it can increase. And so our time can change, and we can represent our time by years or months or weeks, whatever. But what we can do is we can break this down. There's two different types. There's exponential growth and there's exponential decay. Okay, and our time is just that t up in the right hand corner, that's our time, and it tells us how much we're growing by. Now we have also my a here. Our a is our initial amount that we start with. Okay, so just that tiny amount that we start with, or the really big amount for our decay that we go down with over time. Now, our number here in the center is our R. Our R is our rate, our percentage, okay, written as a decimal, and that's important, okay? And it can either be, if it is smaller than 1, if our R is smaller than 1, let me explain that a little bit better, sorry. This whole fraction, this is what we call our B, the whole percentage right there, that is our B. And if my B is greater than 1, it's going to go up and up and up and up. If it's less than 1, we're going to go down, 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 down. So our growth factor is represented if B is greater than 1, and our decay factor is if B is less than 1. So if B is greater than 1, if our thing inside the parentheses is greater than 1, we use this little formula, 1 plus R, to find my rate. And if it's like this, if it's 1 minus R, that means that we have a less than 1 number. I didn't do a great job explaining that, but let's talk about what exactly exponential growth is. Exponential growth is when, if we take a look at these tables, this first one here is a linear growth. It only goes by a certain amount each time. My population, the time is in intervals, but my population is just going down by the same amount each time. So it doesn't increase in the amount it goes down by or decrease in the amount it goes down by. But this one over here, you can tell it's going down. We go from 10,000 to 5,000, 2,500 to 1,250. Each time, we are going down by exactly 1/2. And so this is what's known as an exponential decay. And so we're going down by a factor of 1/2 each time. This is another exponential here. So anytime that I am multiplying by a number, even if it's a 1/2 or by 2, we're going up and up and up faster, 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 like 10,000 times 2, 20,000, 20,000 times 2, 40,000, 40,000 times 2, 80,000. So we go up and up and up faster, faster, and faster. The amount between each one of these is not the same. So this is an exponential growth by a factor of 2. And this last one here, this last one is a linear growth because if you look at this, we're going up by the same amount each time. So don't let that throw you off. We're used to these linear ones where we're going up by the same amount each time, but these exponential, we're either going down faster or up faster as we go. Okay, so let's take a look here at how do we tell if it's growth or decay. So let's take a look at this first one, number 2. So number 2, to tell if it's either going to be a growth function or a decay function, we look at the base. So here I have my base. And for this one, my base is going to be greater than 1. You see that? My base is greater than 1 on this one. I'm actually going to write this above it. So my base is greater than 1. So this one is going to be a growth function. So to figure out how much I'm growing by, what we're going to do is we are going to use this little guy. Since it's a growth, we're going to use this 1 plus R is going to equal my base. So we're going to go 1 plus R equals 1.75. And to find my growth, we're going to minus 1 to both sides, and we're going to get my rate equals 1.75 minus 1 is 0.75. Now, it wants us to write it as a percent increase or decrease. So if we're given a decimal there, all I have to do is just move my decimal place over twice and we get my percent. My rate is 75%. So we have a 75% increase for this one. It's important that we write increase or decrease. Otherwise, it is meaningless. So this one's a 75% increase. You probably could have just seen this without having to do all of this nonsense. Well, we really could have just seen this. Oh, I'm 75.75 over 1. Oh, that's going to be a 0.75 increase or a 75% increase. So if we're above 1, it is an increase. But if it's like this one on number 3, where we're starting with 0.84, this one is, my B is less than 1. So this one's going to be a decrease. And so once again, I could set this up where I go 1 minus R equals 0.84. And we could add R to both sides, minus 0.84 to both sides, and get 1 minus 0.84 equals R. And so we would get 0.16. And so I would have a rate of 0.16. Now, we want to do two things. We want to convert it to a percentage, but we also want to tell, is it an increase or a decrease? Well, in this case, we're going to move my decimal place over twice, okay? And I'm going to have a 16% decrease for this one, okay? So on this one, we had a 75% increase because it was bigger than 1. On this one, I had a 16% decrease because it is less than 1. All right? Okay, let's turn the page. And now let's begin talking about some real-life examples. So number 4, it says the value of a car Y in thousands of dollars can be approximated by the model Y equals 25 times 0.85t, where t is the number of years since the car was new. All right, well, let's write out our formula here to help us as we go. My formula is Y equals A times 1 plus or minus R times the time. Now, I wrote minus R here. And the reason I wrote minus R is because I can see right here that this is less than 1. And so it's going to be decreasing. So this one, the value is going to go down over time, which makes sense because we're talking about the value of a car over time. And unless this car becomes a classic, it's going to be going down, the value is. Okay? So we get Y equals A times 1 minus R to the power of t. And so tell whether the model represents exponential growth or exponential decay. So we already talked about this a little bit. We look at my B, and my B is 0.85, and that is less than 1, right? That is less than 1, so it's going to be an exponential decay. It's going to go down over time. Now, let's figure out what the annual percent increase or decrease is in the value of the car. So this is my B. We're looking how much 1, if it ever is 1, that's just going to stay the same. It's just going to stay the same for forever. Okay? So if it's bigger than 1, it's going to increase by that much. If it's less than 1, it's going to decrease by that much. Okay? So this is 85. So all I need to do to find my percent decrease, right, we're just going to go 1 minus 0.85, and that's going to equal my rate. So 1 minus 0.85, that is 0.15. So my rate, we're going to change this to a percentage. My rate is going to be at a 15% decrease every year. 15% decrease every year. That's why a car usually isn't a very good investment piece. Okay? Now, if we continue onwards and we take a look at C, okay, According to this model, what was the original value of the car? So looking back at our equation, we can tell what the original value of the car is. It is 25. Oh, hold on, because that's my A. But a car that's worth $25, that's definitely not going to work. So what is this hiding? Well, if we look back at our problem, it says Y in thousands of dollars. So that's not just 25, that is 25,000. But my original value is going to be my A. And my A is 25, but that's actually saying $25,000. Okay? So that's what that's going to be. And then D, estimate what the value, when the value of the car will be $8,000. Okay, so we take my original equation that it showed us, and my original equation was Y equals 25 times 0.85t. And it's asking, what is the time, what is the t when the value is 8,000? So what is my value when my y is 8,000? What is my t going to be? All right, so we need to solve this just like we did with our logarithmic equation. So my first step, what we're going to do is I'm going to divide. Oh, excuse me, I made a mistake. Just like I thought that 25,000, okay, just like I thought 25,000 was 25, I need to write in here a bit more accurately as well, okay? Instead of saying 8,000, we're going to write in here 8, okay? So we're going to instead solve it with 8. So we're going to go, we're going to divide both sides by 25, because it's in thousands, okay? So we're going to divide both sides by 25. We're going to get 8 divided by 25 is 0.32. You can leave it as a fraction or you can write it as a decimal. So we're going to have 0.32 equals 0.85 to the power of t. And then I'm going to rewrite this as a logarithm. Okay, so it's important to remember how to do this. I'm going to go log of base 0.85 to the power of 0.32 equals my power, which is t. And so now that's what I've done. I've got my time by itself, and I just need to plug this into my calculator. I'm just going to plug in log of 0.32. Oops, sorry. I'm just going to plug in log of 0.32 divided by log of 0.85 into my calculator to find my time. And if I do that, I'm going to find out that my time is 7.011 after we round it. So I can say that my time is approximately 7 years. When is it going to be equal to $8,000? In about 7 years. Okay, that's how much it's going to go down by. Okay, and then that's going to be, that's when, in 7 years, that's when it's going to be equal to $8,000. Our last question, how much is the value of the car after 3 years? Well, for this one, I just need to plug in that 3 for my t. So we take my original equation, we're going to go y equals 25 times 0.85 times to the power of 3. And I just need to plug that into my calculator. We're going to get y equals 353. And so it's going to be approximately, in 3 years, my car is going to be worth approximately $15,353 after 3 years. Okay? All righty then. All right, so our next one. Number 5 here. Number 5. If a to the n represents the nth term of the sequence, 54, 18, 6, and a to the first represents the first term, then a to the n is, all right, so a to the nth represents just any term in the sequence. We can just plug in and find any term. We got to figure out what our first few are and find a pattern. So that's the important thing, is finding a pattern. So my first one, we're going to say a to the 1. My second one is going to be a to the 2. And my third one is going to be a to the 3 here. So we have my first number, my second number, and my third number. What we're trying to figure out is how to find a to any number. Okay, and so we got to figure out a pattern. So if we look here, we can tell this is an exponential. Each time we go here, from 54 to 18, and then from 18 to 16, you can see that I am dividing by 3. So each time between these two, I'm dividing by 3. Or we could say that I'm multiplying by 1/3. So that's going to be my representation. Now, so let's think about what our thing is. We have our a times my rate, right? And so my rate is going to be 1/3. We already decided what that is. My rate is 1/3. And then my a, we can tell, is going to be my starting point, right? And my starting point is 54. So I'm going to have 54 times 1/3. Well, if I would just multiply 54 to 1/3, that just gets me to what a2 equals. But I want to know what n equals. Well, we can already mark out these, and we only have two options. It's either going to be n, or it's going to be n minus 1. So let's plug this in and check. Let's see here. So if it was n, we could plug in 1 here. And so we could plug in 1, and I could go 1/3 to the power of 1. 1/3 to 1 is 1/3. And so 1/3 times 54, oh, that's going to give me the next one. That's going to give me 18. So that one is actually not going to be the right answer. What we need to do is we need to start off and we need to have 0 for the first one and then 1 for each one after that. So we're going to go 54 actually times 1/3 to the n minus 1. Okay? And that's going to help me set up and find that one for letter D. All right, guys, we're going to go ahead and stop there. Hope this has been some help to you. I'm sure I didn't do a great job explaining this one. It's one of those lessons that is just real tricky to figure it out. But just focus on finding your rate, plugging that in, and please, as always, let me know if you have any questions. All right, thanks, guys.